In this video, we're going to talk about how to deal with splitting up lone pairs in the central atom, as well as how to handle when you have molecules that have charges like polyatomic ions. Generally, what we're going to want to do is we want to make sure that whenever we draw a Lewis structure, oxygen and fluorine at least have their octet satisfied. We don't want to put any more bonds around the central atom unless we have to, because we want that to be as close to octet as possible. So let's start with a simple example, nitrite, NO2 minus 1. Now this -1 charge means that you have to add one additional electron to the Lewis structure. So when you get done drawing your valence electrons, you have to put an extra electron somewhere. Typically, it's easier if you wait until you've drawn most of the molecule before you start adding electrons. You're going to add them where you need them. So if we were just to draw NO2 without the -1, we have nitrogen with its 5 valence electrons, oxygen, each oxygen containing 6 electrons. And as before, we want to form one bond to each of the periphery atoms first. Now we have 3 unpaired electrons in this figure now. One on the nitrogen, one on each periphery oxygen. So if we just pair up our unpaired electrons in nitrogen and oxygen, we've gone from 3 lone pairs down to 3 unpaired electrons to 1 unpaired electron. So what do we do with this extra electron? Well, we can either break this lone pair up on nitrogen, form a double bond. This will satisfy the octet on the oxygen, but now we have an unpaired electron on nitrogen, so we really haven't gained anything by doing this. This is where you're going to utilize your negative charge. Right now, nitrogen has a satisfied octet. It's got 2 lone pair electrons and it's got 6 due to bonding. So if you add another bond, now you're going to exceed the octet. In this case, we're going to take our extra electron and we're just going to pair it up with the unpaired electron on oxygen. This will give us our -1 charge. Now we have both oxygens satisfying octet. 4 lone pairs and 4 from bonding here, 6 from lone pairs and 1 from bonding here. So let's say we have a less intuitive example. Let's say we have phosphite, PO3 minus 3. As before, we're going to draw our phosphorus, periphery oxygens. We've got 5 valence electrons on phosphorus, 6 on each oxygen. And again, we're going to start by drawing our first bond to each of the periphery atoms. Now in this case, phosphorus has satisfied an octet. We've got 2 electrons in terms of lone pairs, 6 in terms of bonds. It's only our oxygens that haven't satisfied octet. They've each only got 7 electrons. So you may be tempted in this case to split the lone pair on the central atom to form the double bonds. But keep in mind, you've got 3 extra electrons to deal with. But let's say you didn't do that. Let's say you decide, okay, I'm going to go ahead and draw my bonds. So I'm going to split the lone pairs on phosphorus. This will get me down to 1 unpaired electron. Now I've got 3 extra electrons to deal with. So I can put 1 here and I can put 2 here, but now phosphorus has massively exceeded octet. Instead, let's just stick with what we had before. We have a phosphorus in its octet, and we have 3 oxygens that only have 7 electrons. But now we've got 3 extra electrons we can add to the picture. So all we're going to do is pair up those extra 3 electrons with each of the unpaired electrons and each of the periphery oxygens. And this will be the Lewis structure for phosphate. Generally, if you have oxygen in a molecule, what you're looking at doing is putting those negative charges on the periphery oxygens. Let's say you don't have oxygen. Say you're working with something like BF4 minus 1. Boron only has 3 valence electrons, and I mentioned in an earlier video, this means it can only form 3 bonds. But we know from the chemical formula that we have 4 fluorines, each with 7 valence electrons. Once we form our first bond to 3 of the periphery fluorines, what we find is that we're out of electrons. So in this case, we're going to use that -1 charge, add an extra electron to boron, and this will give us a bond to each of the periphery atoms. Now let's say we work with a positive ion instead of a negative ion. Well, instead of adding electrons, what you're going to do is you're going to subtract electrons. So if we look at something like ammonia, NH4 plus 1. We start out with nitrogen with 5 valence electrons. We have 4 hydrogens, which means that we're perfectly capable of forming bonds. Now, like the examples before with nitrite and phosphite. You don't want to do anything with that charge until you've at least kind of got a Lewis structure started. So if we draw a line to each of the periphery oxygens to give us our first bond, what we find out is that we end up with one unpaired electron on nitrogen. So this is where our +1 charge is going to play a role. To create a +1 charge, all we have to do is eliminate an electron. So we're just going to erase our unpaired electron, and this gives us our +1 charge.